Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we'll be learning the PN junction using the energy band diagram. So previously in the class we learned that how does the PN junction formed, where the electron and holes flow when both the P and N junction are being connected together. P and N material is connected together. Now we want to understand in terms of energy band diagram. First of all, let's recap a little bit. This is the in terms of energy band diagram, right? So this is the conduction band, this is the valence band, and remember in order for electrons to move freely, it has to be in the conduction band, and for the holes to move freely, it has to be in the valence band, right? So the distance or the minimum energy that required for the electron, this is the bound electron, to be free, is the electron need to gain the band gap, need to gain energy the same or greater than the band gap, then you will get the electron to be here. Okay, and that's energy band diagram. Now I want to talk about Fermi level. Fermi level is the probability of, okay, so Fermi level is the probability of finding free carriers. So if it's in an intrinsic semiconductor, okay, let's see, if it's an intrinsic semiconductor, the number of electron equals to number of holes, right? So the Fermi level, the probability of finding free electron and holes are the same. So the Fermi level is in the middle of the band gap. Okay, so this is for intrinsic. However, if it's for extrinsic semiconductor, okay, so you have two types of extrinsic semiconductor. One is the N and the other one is the P. So let's look at the N type first. N type semiconductor. So this is the energy band diagram. So if it's silicon, then the band gap Eg is specific to the material. So for silicon, it's 1.1 eV. So if it's N-type silicon, the band gap doesn't change. So it's still 1.1 eV. Okay. So this is the conduction band, the valence band. So for extrinsic semiconductor, the band gap energy is the same, though the difference will be in the Fermi level. N-type semiconductor means you have more free electrons. The majority carriers are electron. So for majority carriers electron, the free electrons are in the conduction band. So the Fermi level, if I draw the Fermi level, the Fermi level of an N-type semiconductor is closer to the, so this is for N-type, it's closer to the conduction band. If it's a P-type, if it's a P-type semiconductor, it's a P-type semiconductor. Let's draw the energy band diagram like this. So this is the conduction band, this is the valence band. Again, if it's silicon, the same Ag, so the height of the energy should be the same. So if it's for P-type, the Fermi level should be, P-type means you have a lot of free holes. So free holes, the free holes are in the valence band, hence the Fermi level should be closer to the valence band. So this is the basic. So you have the intrinsic semiconductor, the Fermi levels in the middle, then you have the n-type semiconductor, the Fermi level is close to the conduction band, and you have the p-type semiconductor where the Fermi level is closer to the valence band. This is important for us to move to the second stage now. Okay, so now we know the one that we do here is all for individual material. So there is no p-n junction yet. It's just one intrinsic, one n-type, and the other one is p-type. It's all individual.